Passage 6 is a research passage in ACT Science 59F. We know it's research because we see experiment 1, experiment 2, experiment 3. So we know we're looking at the different experiments. For research passages in our DRC approach, we're going to read, but not carefully. We're just going to read lightly, skim the details, and look for the process and the differences between the studies. You want to quickly look at the passage, think 30 seconds to a minute, to understand the differences between the experiments. So in this passage, we have flameless ration heaters used by combat soldiers to heat meals in the field. That gives us a chemical equation, and the rate of reaction of sodium chloride and iron in the following experiments were used to determine how to design flameless ration heaters. So experiment 1, it looks like they're doing magnesium ribbons of an iron powder. So we have powder, we have a ribbon, we have another ribbon. It looks like we're measuring the different temperatures and time. Experiment 2, it's combined with Fe, which I believe is iron, and we're looking at the moles of it and the temperature. And experiment 3, looks like we're doing sodium chloride, and we have how much is added and the temperature. You get a basic difference of what's going on in the experiment, and then you go to the questions. Number 30, we're using experiment 3. Which of the following is the most likely reason that amounts greater than 0.125 moles of NaCl were not tested? We see this nice little asterisk after the 82 that tells us the solution was boiling. Pretty definitely the answer is going to be H, but we can process eliminate the others. Choice J is easy to eliminate because it says more iron would need to be added. In this particular study, we're testing NaCl, so J is out. F and H says that adding more NaCl no longer increase the reaction rate or would decrease the rate. We know it's not G because it says in the reading the reaction rate increases, and we don't know that it wouldn't increase it, but it's already boiling, so it's harder to determine the data. So your answer is definitively H. Probably could have stopped after you just saw the asterisk and didn't need to process of eliminate. Number 31, based on experiment 3, one can reasonably conclude that as the amount of NaCl increased from 0 to 100, so as it increases from 0 to 100, the temperature rise does what? It increases only as well, so your answer is A. Number 32, we're looking at experiment 3. This is an if, suppose, why question. Anything that has those words in it means you're going to have to add information in. So if a trial had been done that used 0.60 moles of NaCl, so it's going to be right there, the maximum temperature increase would be closest to. So it's going to be between 34 and 50. The only answer choice between 34 and 50 is choice G, 42. Which of the following factors affecting the reaction of magnesium and water, H2O, was studied in experiment 1, but not experiments 2 or 3? So it's not studied in 2 or 3. So I'm just going to process of eliminate. Reaction, temperature. Well, that was studied in 2 or 3. So we're going to say it's not choice A. The addition of NaCl. Well, that was definitely studied in experiment 3. And remember, it says 2 or 3, not both, one or the other. So that one's out. The addition of iron, Fe. They studied that in experiment 2. So that one's out. And so I'm laughing at my pronunciation of iron. And so the surface area of Mg has to be the answer, which is D. Number 34, we're looking at experiments 1, 2, and 3. An engineer is designing an FRH to be used with 100 milliliters of H2O that will most rapidly generate the greatest amount of heat with the least amount of materials. We want more heat, less materials. Which of the following specifications should she choose? So I'm going to start by looking at the 0.125 moles of NaCl. That's the same for all of them. Experiment 3, so we're not even going to look at experiment 3. We'll really just have to look at experiment 1 and 2. So now let's look at, are we going to use 0.5 moles of iron or 0.7 moles of iron? So we're going to look here, 0.5, 0.7. The temperature is the same, so we want the one that has the least amount, which is 0.5, because 0.5 is less than 0.7. So we can eliminate choice H and choice J. Now we have to say, are we using powder or ribbon? So we have 0.10 moles, which is the same. We just have to know which one is more effective, the powder or the ribbon. And if we look at this line, the one with the diamond, that's the powder. So the powder is more effective, so F. It has been observed magnesium and water react. The magnesium hydroxide that is produced forms an unreactive coating. Which of the following models for why NaCl speeds up the reaction is most consistent with this observation? This one's a little bit tricky. It's a little bit to think through, but let's process and eliminate the answers. NaCl absorbs heat. Well, if it absorbs heat, that is slowing down the reaction, not increasing the reaction. So A would be out. Choice B says it binds with iron to inhibit the reaction. Well, that doesn't speed up a reaction either. It inhibits it. So it forms a barrier against the H2O. No, that doesn't work. You have to combine with the H2O. So the only one that works is it removes the coating. A, B, and C all inhibit the reaction in some way. And we want the reaction to speed up. So D has to be the correct answer. Reach out if you have any questions.